Welcome. This is our 5th video in the series on statistics. And in this video, we're just going to talk about a few sampling techniques that are commonly used. The first is called simple random sample. And simple random sample is the sampling technique that all the other sampling techniques will try to employ or try to emulate. So we should write that. All sampling techniques try this. Try to emulate this. And the way to think about simple random sampling is having a giant raffle with the sampling frame or target or population. So every individual has an equal chance of being in the sample, but the other characteristic is every group of size n in the population has an equal chance of being in the sample. So in little n often represents the sample size, and what this is saying is any group has an equal chance. All the groups that are the same size have the similar chance. And we'll see in the other sampling techniques that second characteristic of simple random sampling is not present. Now, the first technique we're going to talk about is the systematic random sampling. And you can use this when there's an ordered list in your population. So there's 100 counties in North Carolina, and say you wanted a sample of 25 of them. Well, the list of counties is organized, or it has a natural order to it, because you can alphabetically organize them. And so if you alphabetically organize them, you can assign them all numbers. The one at the top of the list can be 1, and so on. And so to use this technique, you'll randomly select one number and then choose every fourth county on the list. And so instead of writing counties, you can just imagine them as numbers. And so say you randomly select the 37th county. Well, then you'll just pick the 41st county, the 45th county, and so on. And you can wrap this process around. So you can keep going, and then when you get to 100, you can start over, or you can imagine working backwards from 37. So 36, 35, 34, and you'll pick the 33rd. And in this way, you'll get exactly 100 counties, exactly 25 counties in your sample, and the every fourth is coming from 100 divided by 4. 25 goes 4. This gives you your step length. But you can see that this doesn't have characteristic 2, because it's impossible to have two counties that are next to each other on the list. So if you use systematic random sampling, it would be impossible to get both county 37 and 38 in the same sample, because the way this technique works is you just pick one number at random and then pick every fourth one from there. So after one county is selected, the rest of the members of the sample are determined, and it can never be inclusive of the ones that are neighboring that one on the list. Alright, the next sampling technique that we're going to talk about is stratified sampling. And in stratified sampling, there's somehow natural divisions in the population called strata, and we use those to form our sample in some fashion. So one example is neighborhoods in a city. The neighborhoods naturally divide a city, and then within each neighborhood, we should use different color. Within each neighborhood, you could take a random sample. And you might ask, well, why would you do this instead of just taking a simple random sample across the whole whole city. And one thing that using stratified random sampling does is it guarantees that you have representation from each neighborhood. Via pure random sampling, it's possible that one neighborhood wouldn't have any representation. There could be nobody from that neighborhood in the sample. And if you're trying to get a sample that represents the whole city, you probably want everybody, at least one person from every neighborhood. Well, if you force yourself to take at least one person from each neighborhood by going to those neighborhoods and doing a random sample within them, you might actually get a more representative sample just because by chance, with a simple random sample, you might not get somebody from each neighborhood. Now, it's important to note that we're grabbing at least someone from each neighborhood, as opposed to randomly selecting one neighborhood and then sampling everybody from that neighborhood. We shouldn't do that because we can't expect a neighborhood to represent a whole city. Another example I have here is vegetables in different beds. And so I thought that we could draw a couple different vegetable beds, and say in one of the beds you have your carrots, another one you have your tubers, you got your potatoes, and then the last one you have your lettuce. And so in each one of these, we would definitely want green. In each one of these different beds you have different plants. And if you were to do a simple random sample, you can see how maybe just by a raffle it's possible that you wouldn't get any lettuce or something. But with the stratified random sample, you make sure you go to each bed and just randomly select a few from each of the beds. So, in that way, you guarantee that you have representation from all the different beds. So those are a few sampling techniques, and the important thing to note is they all rely on some level of randomness. And randomness is important here because it eliminates any personal bias in the data collection technique. And that is embodied in the idea that every individual has an equal chance of being in the sample. And for simple random sampling, every group has an equal chance of being in the sample. Alright, that's it for this video. See you in the next one.